Hello, my name is Steve Barnes. Welcome to the Essentials of the VGBA Drain Cover Compliance for public health officials and for anybody who's interested. So the goal here for all of our contractors and non-health officials is hopefully you can see what health officials are going to be focusing on so we can all work together to achieve the same goals. My name is Steve Barnes. I am the Director of Science and Compliance for Aquastar Pool Products. Most importantly, I am the chairman of the Drain Cover Standard Writing Committee, and I've been involved in this committee since 2002. I've been involved in the industry since 1984. I have a passion for this subject because I was entrapped as a teenager for over a minute in a public pool. And so while I take suction entrapment and drowning prevention very seriously, I also am a huge fan of water and people enjoying it safely. And we just got to treat suction similar to electrical systems. It can be very dangerous, handled properly. It's okay for everyone to enjoy. So welcome to the webinar. This is going to be focused on the Virginia Graham Baker Pool and Spa Safety Act and the federal law's goals. So our key learning objectives here today are going to be confirming SOFA model certification. How do we know products are actually compliant with the federal law is step one. That's checking certification, pretty easy. The next learning objective is understanding if a specific SOFA, such as this one, is certified for use over an existing sump that could be something like this, okay? Or another extreme, something like this, okay? So they come in all different shapes and sizes. And so these are sumps. I'll go into more detail on that. And understanding the sumps is critical to understand if a given product is compatible with that sump. And then related to this is the pipe size. So if we look at the pipe size on this sump, it's quite large compared to this sump, which is relatively smaller. This one is 2-inch. This one could be either 3-inch or 4-inch, depending on if you go inside or outside of this fitting. Those are the SOFA models, if you will. They have pipe depth, pipe sizes, and each one of these tested by every model gets its own flow rate. That's kind of what makes, not kind of, that's what makes this pretty complicated right now. And then the final determination, once you know what the cover is, what the sump size and those specifications are, and what that flow rate is, then we need to validate that they are compatible with the highest achievable flow rate by an individual suction system. And I'll go into more detail, but this learning objective is worth stating now and again. The highest achievable flow rating, if we're looking at small pools, I'm going to keep water parks and 1,000-gallon per minute, 500,000-gallon per minute systems out of this, because if we start turning valves to find the maximum achievable, we might cause big serious problems. So we'll leave that to the engineers. Relative to hotel, motel, basically this concept certainly applies to 5 horsepower and smaller pump systems. And that is the highest flow rate that is achievable would be turning off the skimmers or a gutter overflow system. Again, if it's not too big and you can do it safely, turning that off and then seeing how much water actually is flowing through the drain covers. That's the number we worry about. That's what we want to size that system for. It's actually in the ANSI standards about that's how we do it. Then once we go back to normal operation with the skimmers operating or gutter overflow operating, now the flow rate through that system is way lower and we cannot get too concerned over the exact flow rate we see on a flow meter, for example, because that's going to represent the total system. Now, where that doesn't apply is when we go into spas and you have only submerged suction outlets that only go to a pump and then back to a jets with no filter. So it's basically always operating at its maximum achievable flow rate versus a system with a skimmer. So it gets detailed, and we'll cover more of that going forward. Keys today: making sure that the drain covers are certified and listed and labeled. The one I've held up here was available on that big smiley company that sells billions of everything. And this was actually recalled. And I'm going to use this as an example for a couple of ways how to measure it, how to change it, the things that contractors will be doing that the health officials are. It's helpful if they ask the questions and confirm from the contractor, whoever's doing the work, that they do it correct. Making sure that these covers, whichever kind and style they are certified, listed, and labeled. So you find that on NSF, IATMO, UL's website, I think, are the only three I'm aware of that are certifying these covers in the US. If I'm wrong, I apologize for missing someone. Then the sump, we'll go into those details, what the flow rating is of that sump, and then determining the highest flow rate achievable by the individual suction system. Let's touch on the Virginia Graham Baker Pool and Spa Safety Act. So its goals, as stated by the U.S. Consumer Product Safety Commission, or Pool Safely's website, is to prevent entrapments. The mandate compliant drain covers to reduce suction entrapment risk. You can never take it to zero, the risk. If you have water leaving a pool, skimmer, drains, then there's always a level of risk. So we can't take it to zero. It's like electricity. We just can't take the risk to zero, but we have all the tools we need to make sure those risks are managed. So the goal of the act is to ensure public pool and spa meet safety standards. The act can't control behavior. It can't control, certainly me, just kidding. It can't control behavior. It can't control what users do, and it can't control equipment. So it is a product specific regulation. That's why the role of contractors is so important, and local authorities having jurisdiction. They do have the authority to inspect pools, obviously. That's probably why you're here, or you're a contractor that works on them. So, and then promote awareness. This is a prime example what Laura and DuPage County is doing with this program. This is part of a grant program from the U.S. Consumer Product Safety Commission. I believe it's the third one, if memory serves. Now, the grant pays for education and resources and all of that, but let me just make sure everyone understands that Aquastar and myself, we volunteer this. We want to do it as a public service. We believe in helping everyone in the industry, including our competitors. This information is equally applicable to any manufacturer. There's a lot of great manufacturers out there, and all of this should generally apply to the minimum requirements will apply to everyone. This is sort of the summary of the federal drain cover standard. The VGB Act of 2007 mandated that all public pools and spas in the U.S. must have compliant drain covers to prevent suction entrapment. The act requires covers to meet the ANSI APSP ICC performance standard that went into effect as a manufacturer's deadline in 2021. And it's obviously designed to enhance safety and prevent entrapment. APSP 16 2017 is the successor standard to the original one referenced in the act in 2007, which is ASME ANSI A112 198 2007. You're going to find out is covers that are certified and marked with that, or a couple of others, in other words, prior to the 2017 standard, are still compliant. If they're on a shelf, they had to have been manufactured before 2021. And if they're on a manufacturer shelf, distribution shelf at a pool store, in a warehouse, or in a storage room at a public pool, all of those can be installed under the old rules, and they meet the current standard. I'll put a slide up that shows that exact reference. from the federal law. And the key is they remain compliant until they reach their expiration date. All drain covers since 2007 are required to have a service life in years. Service life in years starts at the month and year that it was installed in the pool with or without water, because UV can damage them either way. They start to degrade over time. Okay, so let's dive right into the VGBA 2017 essentials. Okay, suction entrapment hazards. Let's start with overview of what we're dealing with, which explains why this is so complicated. The first hazard, which represents historically from data prior to the VGB Act, hair entanglement was 1/3 of the 150 cases that were reported at the time that we reviewed as the Pool and Hot Tub Alliance Technical Committee. Another third was body entrapment, and that is what happened to Virginia Graham Baker, is getting stuck on one of these, this kind of model, because she was able to, her hip was capable of covering this. You can see it's pretty small. And then she was held underwater. So that's body entrapment. Limb entrapment is when a cover is missing, like a big one like this, right? It's possible to stick an arm or a limb into this hole. Okay. And then the arm gets stuck. We have examples of this happening in pipes with no suction at the extreme. There's just an open pipe, no pump connected. Young girl sticks her arm in and gets mechanically bound. We also have cases where it was a similar case, only with gravity drainage, no direct suction, but a still child gets their arm stuck mechanically. And then, of course, you add direct suction to one of these modern variable speed pumps that are now required, and you have just a real bad situation. So it's just critical that we protect those openings. That is a limb entrapment. Evisceration is the ability to, when it's happened, is small. We have a cover like this. This doesn't quite fit, but we have one of these. It goes missing. And then this is easily sealed by, typically, unfortunately, it's young children who have sat on these things, and I'll leave it at that. And that can happen even if a modern cover is missing. So it's critical that we make sure covers are properly fastened. And then the last one is mechanical, extremely rare. There's only 2 cases I'm aware of. The first one that put it on the radar was actually a necklace caught in a bathtub drain. It showed up in the data. It ended up happening in a shallow play pool with the tipping buckets and all of that. And it was a mom laying on her belly, and she had a belly button ring that got hooked in the grating opening. No fatalities on this, but a little bit of embarrassment. So we include all of the hazards, the federal government does, and the standard writing committee. We look at all of these and address them all the time through the standard. So what is the solution to that? The testing of the standard, and I'm going to show you a lot of that and how it works. The 2 main things, which are very visual, are the hair test and the body block test. We'll show you that. There's also a ton of fastener and material and all kinds of stuff. Any certified cover that's passed, we achieve the suction entrapment testing. We just got to make sure we don't have a flow rate too high for a specific color. That's the second point to this. And the cover instructions have to authorize its use over specific size outlets and pipe sizes and all of that. So this solution is pretty obvious. These 2 are not compatible, but in many cases, it's not nearly that obvious. This is where we really count on our contractors to do the heavy lifting. I know we've had some questions about AHJ's, authorities having jurisdiction. Do they need to dive and measure this? My personal opinion is absolutely not. That's what the pool owner needs to do, whatever it takes to assure their pool is in compliance, typically by hiring a professional, or maybe they have one on staff. It's a water park or something like that. But in my opinion, that is not the role, should never be the role of public health official to go out and start measuring stuff that's underwater, even climbing down in pools, although I certainly understand it happening, we really need to depend on our contractors. If you think about buildings, whether it be the one we're in now, collective or individually, think about high rises. DuPage County is outside of Chicago. You think about those buildings, can health departments assure the rebar and the concrete is installed rightly? Are the building officials? No, we count on contractors. My opinion, that's where we need to be going with the VGB Act. So the drain covers are tested, they get a flow rating. There's a test for finger and limb access built into the standard. If they're certified, they pass that. So I'm not going to go into any detail on that. And then one is really important is strength and UV resistance. And this is a pain in our took us for manufacturers because these strength requirements and UV resistance tests are extremely tough and difficult. And the good news is once a manufacturer gets through that gauntlet, and it is a gauntlet, then I think they and we and society can have a high degree of trust that these products will achieve the goals. And then the final critical thing, and that's kind of what we have to focus on, is the installation and maintenance to make sure that all of these things that are achieved with the original product certification, flow rate, sump compatibility are installed properly and then maintained over time. Moving along, the role of the public health officials. Public health officials are pivotal in the enforcement of the act. Although the drain cover product design and certification enforcement falls under the CPSC's jurisdiction. So all of the testing, how they're figured out, the flow rating, all of that stuff is under the authority of the federal government via the Virginia Graham Baker Pool and Spa Safety Act, Congress designating the drain cover standard as a U.S. consumer product safety standard. So the standard becomes federal law by reference. Under that, the U.S. Consumer Product Safety Commission has exercised their authority to preempt state and local policies on drain covers, how they're tested, their flow rates, and all of that. So that's preempted. States can be more restrictive. The only real example I'm aware of, maybe two, example I'm aware of is some local state code will limit the flow rate through the cover opening based on 1.5 feet per second, how fast the water enters. To give you an idea, this probably for the VGBA testing that in my opinion is 100% safe when followed, this velocity may be 3, 4, 5 feet per second. You go to hockey pucks and spas, they could be over 10 in my experience. Whereas some local codes, when they were dealing with these untested, said, well, this literally doesn't have a flow rate. It was never tested. One of the reasons it's not legal, but there was no flow rate. So we didn't know how fast and 1.5 feet per second worked historically. Now we actually test them. So that's more restrictive, but it's not illegal. In other words, that's not preemptive. So be aware of your local health department regulations on velocities through the grates. Another example is while the standard certainly allows and assumes direct suction, that's how we test everything. So if you picture this drain cover being tested and you'll see this coming up, it's directly connected to a pump. So that's direct suction. Indirect suction is this would go to a collector tank and then the pump would draw water out of that separate body of water. That's indirect suction. And so what we're looking for the role of the public health officials, this is a collaborative enforcement approach that ensures public pools and spas adhere to the VGBA 2017 standard. Now, the CPSC is charged with inspecting public pools, but there's quite a few more public pools than we have CPSC. It's, I think, one of the smallest government agencies. Their budget's a drop in the bucket compared to virtually any other. So there's not a lot of resources, and that's why public health officials are so important in this process. So let's look at the compliance verification process. You're going to see this a couple of times because this is sort of the takeaway. We need to know what the operating flow rate is of the system. I talked previously about the maximum flow being you want to turn off skimmers and overflow systems because that flow is not going through the drains. Therefore, it's not a risk factor. Okay. But you can start with that total system flow rate. And if that number, hypothetically, I'm going to use numbers I know with a product I'm familiar with, is let's say that total system flow, skimmers and drains, is 100 gallons a minute. It's a small motel pool, apartment complex pool kind of a thing. It's basically a residential pool in a public environment. That flow rate might be 100 and let's call it 100 gallons a minute. Well, this is rated for, 105, I think, on the smallest one, all the way up to 250 gallons a minute. So if this sofa system is rated at 200 and the total system is with skimmers running is only 100, easy, we're done. We can go on to the next step. Often that's not the case, especially on old pools. So then we need to know what is the operating flow rate when the drain system alone is running. That's where we turn off the skimmer. Contractors, pool pros who know what they're doing, know they can do it safely. I would discourage health departments from touching anything for a variety of reasons. Get a pool pro, get the pool owner operator to validate this stuff for you. But we got to know what the flow rate is. Then we need to know what the sump details are. What is the sump opening size? Is it a little one like this? Or is it a great big one like this? Or I can get in the screen, or it could be something much larger and unblockable. It could be a channel drain, a circle, very common in bigger public pools, lap pools kinds of things might be drains that are 24 by 24, 18 by 36, and a variety of everything else in between. So that's the sump opening size so that we assure we select a cover that'll fit. Okay. Kind of obvious, but it's sort of a tripping point early in this process. And then the next step is what is the pipe size, pipe depth, and the exit orientation. So if we look this one more time, it has a side port here. So this would be a side exit relative to the pool, but it's also got a port on the bottom. Okay. So it's possible, and it happens that somebody could connect. Let me see if I can point to this, that someone could connect a pipe to this. So this would be a bottom exit. This is a side exit. This sump has both. Okay. So we need to be aware of that, and we'll see the impact on the flow rating coming up. And the final step is to determine the VGBA 2017 flow rating, and that's dependent on the sofa model. The sofa is the top level cover. Okay. So this would be a sofa brand, if you will. This, and then here's a different one, different style, different size. So each of these has their own name. When you attach it to a specific sump with a opening size, it's obviously got to be compatible with pipe size, pipe depth, and pipe exit orientation. That combination in that center column gives you a sofa model number. All this is based on the requirements of the standard. This is the combination that makes things a little bit more complicated. Compliance verification at the highest levels. What's the actual flow rate through the drain? What are the sump details? And what is the flow rating of the cover that's compatible with that combination? So let's move into some definitions that are really important. Now, these definitions are in the standard. So these definitions are therefore federal law by reference. And so the first one is suction outlet fitting assembly. We call them drain covers. Don't be afraid to call them drain covers. But as professionals inside the industry, the contractors, and then also authorities having jurisdictions, it's important for compliance to understand that when we say drain covers, when the federal law refers to drain covers, They're talking about suction outlet fitting assemblies. And that is, quote, all components, including the cover grate, that's these guys, used to attach the cover grate to the finished surface of the pool. So here's one example of cover grate. Here's how it gets attached to the pool. This gets cemented into the pool, and then it's got tested screws that hold it in place. So this is how it attaches. If we go to this, now it's a much more comprehensive product, and the cover attaches to the pool because this whole thing's attached to the pool. So this is called a manufactured sump, the big one I just held up. This is called a mud frame, and this would go over a field built sump, and I'll give you a lot more detail on that coming up. Okay, so that's how this cover grate's attached to the finished surface of the pool, and then how they attach to the individual suction system. So in this case, this is the sofa model, and it would attach to the individual suction system with the pipe. So that combination, how it attaches to the individual suction system. And I'm going to say it now and I'll say it later because this concept is a little bit confusing. And I think I need to hold it back here. This particular sofa, when you look at the specifications, it will have, it's a 12. This happens to be an SSB, no relationship to my initials. And then it will talk about the specifications of 16 inches. This is 18 inches of from the surface of the pool down to the pipe before any reduction in pipe size. So this is all part of the sofa, assuming this is exactly 16 inches, and I'm not sure that it is. And then at this point, once you get out of range of the test hair, then the pipe size can reduce. So let's see if I can get this into view. So the sofa is the big pipe size, and then this would be the individual suction system. There's two parts to this compliance thing. This would have one flow rating this way. This has one flow rating based on the VGBA Act testing and certification. The system itself going to the pump, that's handled by building code. So this is 3-inch. This particular sump, and there's a lot of these out there, this will take a 4-inch pipe on the outside. So the 3-inch pipe configuration is one sofa model, and then the 4-inch pipe would be another. If they connected something to this pipe, it would be yet another. And this could be 2-inch or 2.5. So just in this one product, there are 4 sofa models possible. Each one gets its own model number and its own flow rating. Again, that's why this is get complicated, but that's why we depend on our contractors to understand this and get it right. The sofa model number involves the sump and the pipe and the flow rate. Individual suction system, I just covered in a fair amount of detail, and it can be individual suction system. Again, this is a federal law definition, is a direct suction connected directly to the pump or an indirect suction through a surge tank, gravity overflow kind of a thing that connects to one or more sofas. So it can be a single or a multiple and one or more pumps. So every combination is contemplated by the federal law and all this testing because there's all these combinations in the real world. And then that combination is used to determine the maximum system flow rate of the individual system. So the sofa model number, pipe specific, is used to determine if it's compatible with the individual suction system. And that could be what's already involved in the pool. So a lot of detail, I know, but that's why we have a couple of hours. The last definition that's really important is individual suction system flow rating. And that is a calculation based on the quantity and type of installed sofas. So if it's dual blockable drains, like this is a blockable drain size, and if we have 2 of them, then we assume one is blocked and we use the flow rating of the other. If you have 3, you assume one's blocked and you add up the flow rating. If it's an unblockable, which I definitely couldn't fit in the screen, Then because they're unblockable, their flow rating that is published in the specification is the flow rating while blocked with the body block test that you're going to see. And therefore, because it's already a flow rating based on it block, when you add 2 or 3 or 4 or unlimited number, you add them all together. Another aspect of the unblockables, because they are unblockable, there is no minimum separation requirement in the instructions that are required by the standard or in the related standard ANSI PHTA 7, which talks about spacing, floor, wall, all kinds of things. So we won't go into that standard, but it's a great tool that you can access both the drain cover standard and ANSI 7 at phta.org and read them for yourselves. Okay. Another aspect to be aware of for the VGB Act and the drain cover standard specifically is it does address, because the definition is if you have submerged suction outlets, so if you have a drain that's completely underwater, then, and this water goes to a pump, then it triggers the VGB Act. Okay. So there's lots of systems other than the classic general purpose drain covers that I'll be focusing on here today. All of these are considered suction outlet fitting assemblies. There's the general purpose that I just referred to. Then we have registered design professional sofas. These are the kind typically you're going to see in the big pump sizes, water parks. And that's where the architect engineering firm that does the water park and the building and the towers and all, massive pumps and slides and all of that. Well, if they can handle all of that stuff, they're more than capable of handling the requirements of the drain cover standard. So they do their own design, they do their own certification, and that's a whole category unto itself. But you know what? Those people doing it know what they do. They can communicate directly with the public health officials directly. So we'll leave that to them. Self-contained spa suction outlet fittings. So this is your portable electric spas. They have their own category. They go through the whole hot tub goes through its own testing at UL. So it goes through the drain covers, go through this kind of testing, and then they go get tested again once they're installed. So those relative to self-contained spa sofas, if those need being updated and all of that, in that case, your best bet is going to be to reach out to the original manufacturer because they know what they sold and installed and what it will take to bring it into compliance. There is some retrofittable stuff out there. We have one cover that sometimes works, but by and large, those hot tubs are very specific because of how they're tested. Another one is a swim jet combination sofa. This is an inlet outlet. Typically, it's a combination where you'll have a big nozzle or two in the wall and you swim against it and there'll be a suction outlet around it. So it's this sort of compact unit. All of that gets tested as a unit. This would be another case where the specifics of retrofitting or upgrading or a VGB compliance, reach out to the manufacturer of that would be my suggestion there, because they're definitely unique and custom built suction outlets. A third one is a Venturi sofa. This is a product that just as a spa jet draws air, it's a Venturi system that draws water from a drain. And it's typically used in residential environment for debris removal. I don't know that I've ever seen one in a public pool because it's not an NSF 50 certified system. So I think it would be pretty unusual to run across one of these, but it is a unique category. And the key of all of this is takeaway that applies to everything, including general purpose, is you have to look at every single sofa model and each one has different rules and requirements. So this is not a one size fits all applications. You really don't even need to understand this if you know to just look at the cover, look at the application, and then take it from there. So sofa types have different specifications, instructions, and certifications, each one of those categories. That's the takeaway here. So there's no substitute for just looking at each individual product and installation, if you will. So let's look at drain cover testing impact on the design. So this is the verification process. Again, probably not where I intended this slide, but I'll go through it real quick again, because it doesn't hurt to understand this. What's the operating flow rate? What is the sofa type? What's the size of it? What is the pipe size, depth, and exit orientation? And then that allows us to select a specific sofa model that's compatible. Here is the body block test. Okay. This is the test. It applies 120 pounds of force. And on these small covers, like this size, that's 1, 2, but here's a couple other. This is the test that makes this impossible to certify, because this is small. That body block, you'll see a graphic of it coming up, but that is 18 inches. That's basically my shoulder. Here's an 18-inch ruler, 18 inches by 23. So from the shoulder to the belt, basically, is the size of that blocking element. Let me back this up so it'll replay one more time. I thought it was going to loop for us, but so this is the reason that this can't pass. So during this test on this opening, I think I got a couple. Here's some old ones. So this is a bad one I'm going to show you. Well, they're all not good, but I think, which one did we make? We didn't make that. We made this one. Aquastar made this at one time. So based on this opening and that test with the whole suction of the pump, the hold down force, the pounds of force that would be on a swimmer or a user is over 600 pounds. So this is the style like Virginia Graham Baker was entrapped on. And that math on that one calculated, I think, to 635. Obviously, unless she knew how to roll off, and I don't know why anyone would, there was no way even a strong adult's going to get off unless they know how to break the suction, like a suction cup kind of a thing. So moving on to the next critical test. This is called the hair test. There's actually two of these. This one, and this is real time, so this will run for a minute and a half. I think this one might be time lapsed. I have another video I'll show you that runs the full minute and a half. This one's going to speed up after the hair has been added to this square cover, another different kind of cover. But this is the test. In 1987, when this standard was originally developed and it was voluntary, it had a ponytail test. So it's 16 inches of hair, same process that you're seeing happen here, but it's only 2 ounces of hair. And the ponytail really doesn't block the stick that it's attached to, doesn't really interfere with the flow of the drain covers. So when in 2007, when this full head of hair test was added, it not only goes to 5.5 ounces of hair, which is a lot of hair, as you can see, it also attaches to a mannequin head. And that's really important because of the turbulence that comes around the mannequin head, and by extension, a real swimmer. That radically impacts this kind of drain cover design. And the next video you'll see later is a similar version to this. The mannequin head spreads the hair out versus a ponytail would just go in one side. Let me do this where you can see it. So a ponytail might clump in one side. This test completely fills it up. Same kind of thing. This drain cover has passed that test, but it's a flow rate that's so low that it doesn't apply to a lot of pools. So it's largely been replaced. This design has been replaced with this design. So it's taller, so it can handle a higher flow rate for the body block test. And it's got a lot more openings and a little different design. Well, a lot different design that handles the hair test at a higher flow rate too. So this is sort of how we've got here, and then why the details on sofa specifications are so important, because they are all different. And once again, I have a full-size screen to show you this. So let me, This is perfect. This is the real time hair test video that I was talking about. So you'll see this is going to run for a minute and a half. So while that's going, I'm going to bring up this drain cover again. Okay. So what we have here is, as I mentioned, this was purchased within the last year from an online smiley delivery company, and this is not VGB compliant. So this product was recalled. It's got no markings, no name, no manufacturer, so I don't even know who I'm picking on, so I'm not gonna worry about it. But this got installed. We have to assume it got installed. And so if this is out in the real world, unfortunately, we now have the VGB risk of the entrapment. You can see this and this are very nearly the same size. Okay. So this is a new version of a bad idea. So what do we do? You're not going to see these in public pools. I understand that, but this concept is what contractors are going through for measuring sump depth and pipe size and all of that. So I'm getting out of order on my presentation. So I'm going to come up on slides in the future that we will have covered this, but I'm going to take the opportunity now while you watch how brutal that hair test is. And you can see how that goes on for a minute and a half. And you can see how the hair spreads out because of the mannequin head. Okay, so in this case, what I've done is I've taken these screws off. Okay, so this is the drain cover that's technically recalled, right? So this comes out of a pool. This is buried in concrete. So this is still here. This just became, for purposes, this drain cover, this became a field built sump. This drain can be purchased with a drain cover. This one, wrong size, but you can see there's a version of this that this will fit on. And so when this is sold with this manufacturer's sump, that's called a manufacturer's sump. This is considered a field built sump. Obviously, it was manufactured. So when this combination was sold, it was a manufactured sump. As soon as we replace the cover from this cover's perspective, this is a field built sump, and we measure the pipe size, pipe depth. We look at the orientation. This doesn't have a bottom outlet. Okay. So let's look at the process. So now we have a cover. This one is compatible with this sump design. So let me turn it around here. So it's got this particular coupler, and other manufacturers make similar things that'll adapt to different sizes. Kind of known, we call it universal fittings. I'm not sure retrofit is common that the other manufacturers have. So be aware, but this has the ability to adapt to all different kinds of fasteners. And so in this case, it's a direct replacement. So here are the screws that came with this product. That's in a requirement of the compliance. And come in good shape on time. Yeah. So this will be, I think, good value. Apologize, this is a little wonky because I've never done this before in a webinar. So we secure this adapter plate. And let me say one thing generally, our instructions, so I can only speak for Aquastar, is you want the screws to be snug, whether it be these screws or the screws that hold the cover. Okay. They're not wheels on a truck or a car that are going to vibrate loose. They're not engine mounts where we need to do giant torques. So our torque specification is snug. And that means you want to visually take the screw down until the screw itself is touching the plastic. It only has to keep the cover in place so that a kid or teenager problem, when they try and take it off, because that's what kids do, also sometimes intoxicated adults, but they try and take it off. There's nothing for them to grab. You have to use a tool. So don't over torque the plastic covers. Now follow the specific manufacturer's torque instructions. Aquastar's is make it snug. And why this is important. Oh, where'd it go? Where'd it go? Where'd it go? Here it is. Okay, so here's yet another old cover, and this one was way over tightened. See how that screw hole is broken out? And there's other examples where it's cracked, and that's caused by over tightening the screw, where that leads to them being broken and missing. So don't over tighten it. Okay, the sump opening size impact on a sofa. I don't even know if I read that right, but you can read it. I'm going to move on. Blockable versus unblockable. So here's that graphic I mentioned, the 18 by 23 inches. You can see the 99 percentile man, how it fits over that. There's a two-step on determining blockable and unblockable. Is the sump opening, so is the opening in the pool smaller than 18 by 23? This is an obvious yes. So this is always going to be classified as blockable, no matter how big a cover we put over the top of it. So even if we put, and we often do, put bigger covers over small openings, if the opening can be shadowed by that body blocking element, then it doesn't matter about the cover. That's considered a blockable suction outlet fitting assembly. And then you can see the unblockable channel drain, which is the strip drains. The one on the lower right would be a 24 by 24, still unblockable, but a lot of it gets blocked. And then the circle on the left is a circle drain, and one edge sticks out of it. And so that's why that is classified as unblockable. In all cases, the arrows, not the blue arrows, but the black arrows, are pointing to the open area of the drains. And that's what's giving it its flow rate. That's why they can be flat and flush mount, is because water can flow around them. Versus a blockable, the cover has to stick up so that the body block won't seal and water flows under it, or the body block or the body won't seal and the water flows under it. Okay. So blockable system flow ratings, this is another aspect. So a blockable cover can be flat and flush mount. Not all of them are. They don't have to be. It's up to the designer. But from a test standpoint, they can be. And as I mentioned previously, blockable system flow rating is you subtract the flow rating of one from the set. Now, these are two different covers, obviously, but because either one of these can be shadowed by the blocking element, it's smaller than 18 by 23, we assume it's covered and we use the flow rating of an uncovered one. And so you subtract one from the set. The reason we use set, if you have 3 of these, then you just subtract 1. If you have 4, you subtract 1. Okay. And again, that is how it's done under the VGB Act, the drain cover standard, which references one, it's in manufacturer's instructions because federal law requires it, subtract 1 from a set of blockables. And then also it's in ANSI 7, which is also referenced in the drain cover standard as how we determine the flow rates. So blockables, assume one's blocked. It used to be a third, 66%. It was confusing before. I don't even remember what it was. So anyway, be aware that changed in 2017. Well, it went into effect in 2021. The others, when you have an unblockable, because they're unblockable, and I said this previously, is you get to add them together. Another critical thing relative to the federal law on ANSI 7 is they do not have a separation distance. Now, for contractors and designers, if you're putting unblockable drains out in the floor of a swimming pool, put them at least 3 feet apart. Don't drive everyone crazy forever on having them close together when there's no practical reason. Where it matters being able to move them closer together is the footwell of spas, small bodies of water, particularly catch basins and things, but for sure the footwell of spas, because they wouldn't fit otherwise. And they're tested each being blocked. So that's where there's no need for separation. But again, if they're out in the floor of a pool, new design, separate them by at least 3 feet. But in a spa, please be aware they can be closer than 3 feet. And if they're retrofitted to get a old spa up to new flow rates, putting in unblockable drains is a common option that sort of scares health departments who don't, because they want to see the 3 feet. Understand it's safe and it's allowed, and it'll give us the industry and the property owners a lot of flexibility to get to really high flow rates without jeopardizing compliance or safety. So that's the significance of unblockables. Well, I just covered the advantages. They can be flat, they have higher flow ratings, they take up less space on the floor. And most important, there are no reported entrapments when, important qualifier, when the cover was properly fastened. We had a South Carolina incident a few years back where it was a 36 by 36, two 12-year-old boys playing around for literally hours of surveillance footage of this. And then they discovered this cover was not screwed down. It came with screws, but they weren't used. They lifted it up. One of the boys gets down into the sump, 36 by 36, had a 6-inch pipe, and his whole leg went in it. Very fortunate that there was a first responder on vacation. It was a vacation kind of a venue who happened to be there, saw it happen in time that he went down, started giving mouth-to-mouth resuscitation while recruiting other parents. And so there was 3 or 4 of them that took turns for 9 minutes giving this boy mouth-to-mouth resuscitation till they could get somebody to get him into the pump room to turn off the pump. So the problem here is not the locked pump room. The problem was the cover was not fastened. If the cover would have been secured, the little hooligans wouldn't have been playing around on it, or they would have tried, it wouldn't have come off. Okay. So that was an unblockable for sure, 36 by 36. There was another one in Thailand that was 48 by 48 or meter by a meter. And there, a teenager lost his swim goggles through the grate. It was so heavy, stainless steel grate, that they never screwed that one down. And he was a strong enough teenager to lift it, swims down into a 4-foot deep sump, has 16-inch opening, and like the current of a riptide or a canal, it just washed him to the collector tank. And so that really wasn't suction, it qualifies at it. But I bring that up to make the point that from a health department and plan reviewers, these unblockables are a pretty good solution. My favorite part is they can be flat and flush mount. Certainly the higher flow rates make it very convenient for modern systems. Okay, let's look at the sump compatibility basics. So here is the definition of a sump. This is the vessel, the space, I added that, between the suction outlet cover grate and the piping. And this may be manufactured or field built. So that's why manufacturers can sell covers with a mud frame to go over a field built brand new installation. This is legal, and you can see in the picture there where the mud frame gets buried in the concrete, and then the rest of the sump is formed by the outlet. So this is the sump. Okay, so the one on the screen is, let me pull it back so we can see it all. It's going the wrong way. There we go. So they sort of match. Okay, so this is just a manufactured version of a field built sump. But as soon as that original cover comes off, now this is classified as a field built sump for purposes of compliance. And we just look at pipe size and measure the depth. The federal law says that the drain cover can be manufactured and sold with or without a manufactured sump. I will take this opportunity to talk about F. So if you look at figure 5 from the specification, you'll see the very bottom letter F, and that is measured from the surface of the pool down to the nearest point where the pipe can be reduced. In the case of Aquastar, we use 16 inches universally because that's the length of the hairs. Why this matters: to get to the F, so that's with this installed. So this becomes the suction outlet fitting assembly. This is the sofa. Notice how it matches figure 5. And what I want to point out is this is 3-inch pipe, and we can come from here to here 16 inches. If you run a string line, measure 16 inches. So it's down to the pipe and then over. At this point, this system, we would use the 3-inch flow rating, and I'll show you that coming up. Okay. So this would be a 3-inch specification, even though here it reduces down to a smaller size. In this case, I went to the extreme 1.5 inch, so it would be really obvious. That's what F is all about. This is important because if you have old small pipe in a spa or pool, wherever, and they're chipping out the floor to install a new drain cover because they don't, what's there won't work. Maybe the fasteners are damaged, whatever reason, they're modifying an existing pool that has small pipe. The flow rating on this, memory serves, I'm hypothetically going to use, I think, 163 gallons a minute for 1.5 inch pipe. And the exact same cover with 3-inch pipe, I think, is 200. Huge difference in the safety flow rating. And so what we would want, if the pump is capable, say 164 gallons a minute, and the 3-inch flow rating is 200, then this system's compatible with that, even though this would not be. Okay, because then we would have to use the 1.5 inch flow rate if this is within 16 inches, like you see in figure 1. That's an important thing for contractors to understand because it's a tool. If you're taking single drains and splitting it into 2, highly encourage you to use big pipe between the drains, whether it be field built or like a sump like I was just showing you. And then the T you can reduce down to that smaller pipe. So you don't have to go, you don't need to change the piping all the way back to the pool. ANSI 7, which is referenced in the federal law, absolutely allows you to use the existing pipe. What matters is the suction outlet fitting assembly. This connecting pipe is what matters relative to a specified PVC pipe sizes based on this, not the smaller pipe out here. Really, really important to achieve compliance, albeit it could be evaluating what's actually in a pool. So it's just confirming that, or it could be they're going to do some remodeling work, taking a single drain, splitting it into 2 is most common, in which case going with bigger pipe to the T can get you really big flow rates. Like with this cover, if you use, I think it's 3-inch, it might be 4-inch, but if its highest flow rating is 150, its lowest flow rating on 1.5 inch, memory serves, is 63. Pipe size makes a very big difference. Some specifications. So again, this is federal law. This is 351 from the standard I mentioned previously, that you can go to phta.org and search on standards, and you can go view any PHTA standard for free, view only. So you could go read this, you could go read ANSI 7. Obviously, you can buy the standards too. So in section 351, sump specifications, this is what it says. Cover grates shall only be installed on sump configurations authorized by the manufacturer's installation instructions that result in a unique sofa configuration. That's the 3 chart thing I showed you multiple times, and we'll show at least once more. With a specified certified flow rating. So pipe size, pipe depth, pipe orientation, specific cover will give you a certified flow rating. And then that cover can go over manufactured sump, that's one that came with it, or anybody else's, or one that's made in the concrete. So this is federal law that says you can't just install a cover over anything. It has to be in the product specifications. The manufactured product specifications, a certified product per section 3511, the third-party certifier, NSF, IATMO, UL, are supposed to validate that All of this information is provided by the manufacturer before they certify a specific sofa model. And that is minimum suction pipe, could be more than one, minimum suction pipe opening depth below or behind the finished surface of the pool, minimum pipe size, and I'll go into more detail on the minimum pipe size, pipe orientation, that's the bottom or side, and then the minimum suction pipe length before reduction. That was this conversation. But this all becomes the sofa, and that's the critical thing here for compliance. Another thing that merits mentioning, this is not widely misunderstood because it's been around since 2007, is they also have to be confirmed to be compatible with the floor and wall. So when you test a drain cover on the floor with each pipe size and all that, it gets one flow rating. As soon as you put it up on the wall, you have to redo all of that testing again. Everything being equal, let's say this cover was on here, tested this way with this very specific sump would be one flow rating, put it on a wall, and it's enough. The measurements, how you do it is all basically the same regardless of orientation. It's from the surface of the pool, whether it be the wall or the floor. And the drain covers can be certified. It's up to the manufacturer. They can be wall only. Some of the equalizer fittings are only tested on the wall. It can be floor only. Some of the unblockable debris removal drains or just drains in general, the big circles, are floor only. Just because we haven't tested them on the wall, we don't see a use case for that. Or they can be both. These guys I've been showing you is a classic example of they have flow rating floor and wall. And so each one is a different sofa model. So let's talk about assessing the sump compatibility. So here's that verification process. So now that I've buried you with a lot more detail, let's look at this again. Operating flow rate would be the total system. Again, if we have a drain cover that can handle 200 gallons a minute with a specific sump configuration, and the total system flow rate with skimmers running is 164, then you don't need to worry about turning off the skimmers to find what the flow rate is. If this drain cover, let's say I'll use a smaller one. I don't know what the flow rate is, but let's say this drain cover's flow rating was only 100 and the total system is 164. Well, now we need, with skimmers running, now we need to turn off the skimmers and look at the flow rate through the drains only. And if it drops, when you turn off skimmers, the flow rates plummet, typically speaking. And so you might find that the actual operating flow rate is only 80 gallons a minute, very typical for floor piping systems, in which case then the drain system flow rate works just fine. So that's, I've said that a couple times, I might say it again. Some details, we've come to that. What's the opening size, pipe depth? And then what is the model specific flow rating to make sure all three of these align. We do this. This is sort of the key. We do it all the time answering questions. You hit these three buckets and we achieve compliance on a daily basis where it didn't look real obvious when we started. Okay. So understanding pipe size and flow ratings. This is important. Again, this is federal law. The highest flow rate that is achievable by an individual suction system in accordance with ANSI APSP ICC 7. And I think the full title of Suction Entrapment Avoidance Standard, something like that, something similar to that. This is the one that it says turn off the skimmers of the gutter overflow, and the maximum achievable suction system is going to be 100% water going through the drain system. And with variable speed pumps, because now those are mandated by the Department of Energy, if they're 5 horsepower or smaller, I've got that wrong, but you get the idea. It's the smaller ones, then they have to be variable speed. So what is the achievable flow rate? That'll be the highest selectable speed that someone could walk into a pump room and push high speed. And what is that speed deliver? The reason I say selectable speed is because ANSI 7 allows for locking out the pumps themselves. You could lock valves in a partially closed environment. So there is allowance to restrict the flow by the speed of the pump to keep it within range of what the pool needs, turnover rate, function, all that. Obviously, we're going to start there. But if the pump is capable of 200 gallons a minute and the system turnover rate is 140, it's absolutely appropriate that you could slow that pump down, save a lot of energy. That's another presentation, and achieve safety while maintaining the turnover rate. Absolutely allowed. So be aware of, there's some little hidden jewels in here, achievable by the individual suction system. Individual suction systems don't count skimmers or gutter overflow systems. Really important to achieving compliance, because if you just go with the maximum flow on a published curve, a big percentage of pools are not going to comply, when in reality, if we use this and measure it, they are in compliance. And I would say that's one of the big takeaways from today, actually. Here's what the ANSI 7 says about measuring flow rate. So health officials, authorities having jurisdiction, this is your two ways to make the contractor or the public pool owner operator prove to you that they're in compliance. So, and that's measuring a public pool with the flow meter accurate to plus or minus 5%, installed in accordance with the flow meter manufacturer's instructions. The flow meter must be certified in accordance with NSF 50. So it's an NSF 50 certified flow meter. Now, we see those all the time on public pools, and we don't trust them all the time for good reason. So you have a couple of options here. If it's just an old flow meter that was installed properly, meaning it's not right up against an elbow or something like that, or its instructions say it can be, there's one of those on the market, basically is a check valve of all different sizes, and that system doesn't matter where it is. Great option for measuring flow very accurately with a flow meter. Let's just say we have a rotometer, the clear with the BB, as I like to call it, and it's installed in plenty of space, but you don't, as an authority having jurisdiction, health department, you don't trust it, right? So one, it's easy enough to say, hey, contract, the path of least resistance for them is put in a new flow meter, or maybe even just put one in temporarily and say, well, this one looks terrible. The original, it's faded and it's been here for a lifetime, but it's still accurate. Okay. Compliance achieved. You can trust that flow rate. If none of that is possible, then that's where you would measure TDH by using the pump curve. So let me quote this so I get it right. Measure an existing pump system TDH at the pump's drain plugs using a pressure and vacuum gauge reading, and then looking up the flow rate using the manufacturer's certified pump curve. Or we're going to look at the product specifications, and then we're going to look at the effects of pipe size. So what I want to point out here is this is before the VGBA 2017. And if you viewed the prior seminar, will look very familiar to you. Used to be before the 2017 standard that drain covers got a flow rating for the wall and another for the floor, regardless of pipe size. So one test covered everything. And that's what these specifications look for. Now, once you go through and test every one of these sofa combinations, and this drain cover's being tested even now, continuing to add different configurations, now you can see there's a lot more information. So one of the things that used to be the flow rate would be engraved on the covers. And now if you look, if it's got multiple flow ratings, it'll say see instructions or specifications in this case. Okay. So specifications have changed. Ours looks different than the other guys. We, the manufacturers, do it differently, but ultimately all of the certified products are going to have the same information per the standard. And this is where, if you look, oh, I was right. It is 63 gallons a minute on the 1.5 inch. So here what you have is pipe size, pipe exit orientation. In our case, that's the little B. That means the bottom So that's going out the bottom of one of these sump buckets. A little S means a side coming out the side of this. And this is true if you put this on a wall. Okay. Let's see if I can figure out how to do this in the view. If this is on the wall, then this is still the side, right? And if it's on the wall, the B would be back. So it's bottom and back is sort of, this is a point of confusion. I'm trying to knock out all the phone calls now. Now, what I want you to look at is the effect of the pipe size. So let me pull up my visual aids, and I don't have a bigger screen coming, I hope. So if you look 1.5 inches, this is 1.5 inch pipe, and this is 3 inch. Big difference, right? So if you look, this flow rating is 63 gallons a minute and dropping down in zero sump, meaning it's the covers. This is right flush with the surface of the pool. Okay, that's zero sump. So there's no gap. This is just sticking out of the concrete, if you will. That's zero. So that's 63 gallons a minute. If we jump down to the 3-inch one sticking right out of the surface of the pool, same thing, where it's flush with the pool surface, its flow rating is 138. Okay, the pipe and the hair are going to go exactly the same distance under the cover. Why the flow rate is different is because more water and there's less suction on the hair itself. There's more room for the hair. If you think about a ponytail, virtually fills this versus here, there's low suction. And so that's the impact of the flow rates. You look down this list and see 63, 119, 119 twice. I'm looking at the zero sump. 3-inch is 138. 4-inch is 175. So you can see pipe size has a big difference. It also is really important. It's sort of frustrating. It shouldn't be frustrating, but it's a pain to do all this testing. It's a pain to inspect all this stuff. It's a pain to deal with it from an installation and maintenance point of view. But look at these flow rates. It is the right public policy. Much like we on the electrical system, I've referred to a couple of times where, electrical systems, the first safety device was the Frankenstein switch, but it had a really nice rubber handle on it. So grab that and life's good. Don't lean against the switch on the wall, though. That's a bad day, right? So we said, okay, that's not good. So we did switches, houses then, and that was just directly wired to the poles outside. They were crooked poles at the time, but they were outside, right? And then then we came up with fuses. So if there was a short circuit, it would sort of disconnect. Then we went to breakers. Now we've gone to GFCIs that are super sensitive and used everywhere. We've progressed in the same way with the suction entrapment avoidance in the drain cover standard. Used to, one switch covered everything, one fuse, one breaker. Now this is sort of the equivalent of a GFCI relative to complexity. What we're looking at here is the maximum flow rate of a pump based on the manufacturer's pump curve, right? So here we go out, the end of the high speed, max speed is 175 gallons a minute. And this pump gets installed on pools with this size pipe all the time, mainly in the residential world, but it could happen in the public pool world. Probably rare, but it could. So let's look at if we apply the max flow as a policy as a health department, we're going to be failing a lot of pools. And let's use the 1.5 inch example. So the design flow limit for 1.5 inch pipe in a public pool for this is 38 gallons a minute if you were to design a public pool today to the modern building codes. So you could see this pump is totally incompatible with this piping system. I don't have video in this. I think I showed it in the previous presentation where we tested 1.5 inch pipe, no drain cover. Well, we did it with drain cover first and then no drain cover. And at 150 gallons a minute, the water vaporizes as it enters this suction pipe. Literally turns to vapor like a cloud. Very short order, the pump's going to cavitate because it's not getting any water. But to give you an idea, the max flow rate through 1.5 inches Even in a laboratory, you can't get to 175 gallons a minute. Why do I emphasize this? Is please use the actual flow rate of the pump in the piping system to determine compliance. Compliance elements per federal law: pipe size, opening depth, and exit orientation. You've heard me say it a lot. Let's look at it a little bit deeper now that you've heard it. Minimum pipe opening depth. It's a minimum. Okay. So this one, for example, happens to be 3¼ We've tested down to 3 inch, so 3 inch deep. So you would use the 3 inch pipe depth. We've also tested it at 6 inches. We've tested it at 0. And 0 is again where the pipe is very shallow, right? Each one has its own flow rate. You have to use a flow rating based on the pipe depth that the actual installed pipe is deeper. Use the shallower pipe depth for the deeper pipe flow rating. Hopefully that makes sense, because that's another important one. You can always go deeper. You can't go shallower. Identical to the minimum pipe size. If there is a flow rating tested with this size pipe, okay, and that's the only flow rating for some cover, and you go to the pool and find out it's 3 inch pipe, this is the flow rate to use. So you can always use deeper pipe. You can always use a shallow pipe flow rate for a deeper pipe, and you can always use a smaller pipe size for a larger pipe size. Really important, because it happens day in and day out in these pools. And then exit orientation. Probably the majority of pools have just a pipe sticking through the bottom. Therefore, that's what the manufacturers, certainly this one, focused our testing on. You can convert it. It is happening. Let me show you what that looks like. Here on the left is going to be the bottom exit pipe that I just described. That's this, okay? Underneath that concrete, there's going to be an elbow, because the pipe's got to go to the pump at some point. The drain cover standard tests require that even with a bottom exit, that the test lab put an elbow as close as practical for the design, the sofa, the test figure, and then it goes horizontal to some pump in a lab. Okay. So these two are identical relative to their flow rating. The one on the right has been modified. It started out with a side exit. Then the pipe and elbow was placed inside. This case, it works hypothetically in this example because the flow rating had a 3-inch bottom exit and there was room for the pipe and elbow. And this was 4 inches in this example. So it's deeper and it's bottom. And now we have a sofa that a cover is compatible with. And the last element, this mannequin head is waving back and forth like 18 inches. Notice how the hair just goes to the drain. That's because hair travels with the water. And so if it goes into the sump on the right with the exposed elbow, it's going to go into the pipe. If you test the sump on the left, the hair is going to go into the pipe. And then the test results and flow rates are absolutely identical. This is an absolutely viable option. We put it in our technical bulletins and letters authorizing it as a manufacturer because we actually tested it. So we know with confidence. And physics are physics. So, there's nothing special about our elbows compared to anyone else's. So this is allowed. Another form of modifying. So here in the upper left, we have a 12 by 12 and its flow rating, actual installed flow rating, was not big enough. The 12 by 12 cover, which is still huge, but so this is a 12 by 12 cover. The flow rating on this 12 by 12 didn't achieve what the pool had to have for turnover rate. So what the contractor did per our specifications is modify the pool structure. You can see the 12 by 12 in the middle and took it out to 18 by 18. Now, this is, again, a bulletin that we've specified, and you can see the orange surface on the left is where the pool structure had to be chipped down, and then the 18 by 18 frame installed. And you can see the finished product on the right. And you notice the orange, there is room for what's called a flow path. And the reason we include this in our authorization, again, is because we've tested it. So if you look at this sump, while this is round, right? See if I can get it in the picture again. While this is round in the 12 by 12 square, that's irrelevant. The hair follows the water. It doesn't matter. But look at this profile. See how this is pretty. Let me bring it closer. See how there's this area here matches the orange area. Sorry, I just banged the microphone. Matches the orange area there. That's why we as a manufacturer can publish this, because we've tested it. We know it'll work. And the fact that this one is plastic and that cement, or that in the picture is rough cement, does not change the flow rating at all, because the hair is just going to follow the water, just like stuff follows water out of a bathtub, water, sink, whatever. All the water is going to go out a drain. Physics are the same here. It's just underwater. Existing product compliance. Actually, this is one of the questions we received yesterday. So this is what the federal law says. Sofa components that were manufactured or installed before the effective date of this standard, that was May 24th, 2021, and that meet APSP 16, that's the old version of the standard, shall be considered in compliance with this standard. So that's really important. So let's talk about the equivalent markings of APSP 16, 2011. That's what's referred to in the current standard. Drain covers can be marked with APSP 16, 2011, VGB 2008, ASME A112, 1908, 2007. They all mean the same thing collectively, VGB 2008. Let's say this was certified to the VGB 2008, one of those, and it was manufactured before the date, but it's never been installed. This cover can be installed in a pool tomorrow, and it's completely legal following the old rules under federal law. As soon as it's marked VGB 2017, which this is, shocker, then you have to follow all of the sump depth and all of that. So understand existing pool compliance. Now, one of the things to keep in mind is the phrase that says it meets APSP 16, 2011. Part of that standard says you have to replace the drains at the end of their service life. Okay, these probably are 5 years, some are 10, some are 3, some are 7. So you're going to have to look at the specific cover. So if this is installed, let's say this was installed in 2016 to keep, no, it's too old. Let's say this was installed in 2020. This standard became effective in 2021. So this would not need to be replaced until next year, because that would be its 5-year lifespan. So hopefully that makes sense on existing. I think there's 2 more of these, Laura. This explains what I just did, that VGB to APSP 16, 2011 and VGBA 2017 both require replacement of drain covers. Service life begins at installation with or without water in the pool, because if they're out in the sunlight, they're going to UV degrade. Once expired, drain covers do not meet the standard, and then they must be replaced to be in compliance with the standard. I've made it to the end of the slide deck, and let's take some questions, Laura. Or you can give them to me.
Yeah, Steve, thank you. Thank you so much. I will definitely be watching this webinar again a few times for all of this excellent information. Thank you for sharing your expertise. And it was
Fire hose.
yeah, the firehouse we appreciate. Thank you. So I'm going to start with a question received from the chat. Are screws coming with covers always mandatory now?
Yes. So you have to use the screws that come with, I keep ducking out of screen because I have a bunch of stuff behind me. So this cover that I've showed a bunch of times has this sort of screw kit in it as one example, unlike this cover that will only have 2. These are not the right screws, but you get the idea. Okay. In any case, when you were to buy, they brought me one because they said I would need it. And what do you know? They were right. So here's a retrofit replacement cover in the bag. It will come with obviously instructions, and then somewhere, if I can get them, it will have the appropriate screws. And so that's a requirement of the VGB Act. Significance of these is they have to be 316, and that's a highly corrosion resistant type of stainless steel so that chlorine won't attack it. And yes, you do need to use the screws from the covers. And when you get a replacement like this, even though it's going to fit directly onto this mud frame here, that those screws at their 316 are probably going to look good, but that don't use them, replace them with the ones that come with the cover.
Hey, another question. What is the easiest way for facilities to get certificates of compliance for their main drain covers?
Ours are easy, for sure, and obviously I'm familiar with it. You can go to aquastarpoolproducts.com, search on the sofa that you're after, search by 10-inch channel drain, whatever the case may be. In the list of information, you will find that general certificate of conformity from Aquastar. We do that because of all the different flow rates. It's got a QR code on it that'll be useful. It talks about ANSI 7 compliance, so it's sort of a hybrid. Other manufacturers, they're printed in their instructions. I've seen that, and the other manufacturers will make them available online. So kind of a hybrid. By federal law, the manufacturer is required to provide it if you ask. So health departments, if you can't find it online, call the manufacturer. It's kind of a pain, but call them. They are legally obligated to provide it. And if they can't, then it's not a compliant cover.
Another question. Why do standards keep changing?
Good question. So at the highest level, ANSI standards, American National Standards Institute standards, have to be reviewed at a minimum every 5 years. And if they are not reviewed within 10 years, they go away. And so even standards like this, where it's the pipe size, now these are ASTM standards for pipe size, fitting, and all of this. These standards are not changing. There's actually two of them. There's the fittings and the pipe because we don't want them to. In the case of the drain cover standard, it's in revision right now because it has to be. And I can tell you so far what the committee is looking at is clarifications. Most of the work is on how the hair tests and body black and all that, plastics, all kinds of lab stuff is the majority. Beyond that, what's on the agenda is improving instructions and specifications and clarifying some stuff so that this current policy will be easier to use. We had a meeting yesterday on the standard. Probably we hope that we'll wind down by the end of the year and publish, and then the CPSC has to approve it. So it'll be a year, at least a year, if not a year and a half to two before this standard will change again. But right now, I feel confident that everything we've talked about here today will not change. How the test, some of the flow rating, some stuff like that may change in the background, but I don't anticipate, and I will fight if they want to change it to VGBA 2025, for example. Let's leave the 17 alone because it's marked on covers and the requirements are the same. It would have to take a radical change to do that. And I'll go back to the electrical thing. The electrical systems have changed over time as we learn from events. No different on pool codes and standards. As we learn things, as we have to adapt to variable speed pumps, for example, and other things, the standards really need to change to keep up. ANSI standards have to be reviewed every 5 years. My personal goal is we will get this drain cover standard as solid as this fitting so that we can look at it. Other people in the future can look at it and say, yep, no, all that still works. So no changes. But that's a long answer to why that's true.
And we had a question. How does the newer variable speed pump relate to VGBA? Which I think you
So
just answered.
Well, I touched on it. That's certainly one of the factors. So the drain cover standard requires us as manufacturers to put in our instructions that so all of them will have it that say if you change the flow rate of the system, you must reevaluate the suction system. So if you go from a single speed pump to a variable speed pump, they're by definition, they're way more efficient or they can't pass the new federal law for variable speed pumps. So they're going to be more energy efficient and they're also going to be more powerful. Energy efficiency and performance go hand in hand. Cars, doesn't matter. And so what happens is now potentially you put a new pump on, it could increase the flow rate to be out of range on the cover. So that's one aspect of the variable speed pump is they're generally more powerful. The other thing is they have a selectable speed. So we will always use the high speed, and I showed that in the 1.5-inch pipe example. We'll always use the high speed setting, but understand under ANSI 7, under federal law, those variable speed pumps could be slowed down to the pool turnover rate, maybe what they need for what backwashing or something like that, but they could be slowed down and then locked. And now that's why I made the point is the highest selectable speed is what it takes for VGB 2017 compliance.
Greg asked, can you please provide clarification on what is meant by pipe offset E in figure 1 for sofas designated with side outlet pipes?
Sure. So let me apologize right up front is I wish I had not taken the shortcut to use the what I call the VIN number. This is unique to Aquastar, so our competition was way smarter than I was in this regard. What the standard says is that the test lab has to document what was tested. So I've been talking about these sofas. Okay. And so what we do is to document that what was tested is we measure A is pipe size, B is pipe depth, C is like this edge over down to this edge or here. And it says we have to measure the shortest distance and then what is the offset? There's like, well, it's C, D, and E describe the sump and they are used to document in test reports what was tested. They are not part of the federal law of what needs to be inspected in the field. That's what we have recently clarified. So you can avoid them if you have an old specification that only has figure 1 on it, and that's the one with the F, A, B, C, D, and F. Okay. Go to Aquastar's website, download the newest one, and you will see it has a figure 2 that is from the standard that talks about pipe size, pipe depth, pipe orientation. That's what's required of federal law. That's clarified in our new specifications. Ignore C, D, and E. And the reason being is it says we have to do the minimum, right? So in that, we measured from this edge to the pipe. Let me do it this way. So we had to measure from this edge to this pipe opening to document this physical sump. If you measured it somewhere else, the dimension is different. So it doesn't work as a compliance point of view. Apologize for going into detail, but it's very confusing. I understand. So in a channel drain, where do you measure it? It's 10 inches to the pipe, the 3-port channel drains for those not familiar. If you measure it from, it's a 3 by 32, where do you measure it from? So those measurements are only really useful for documenting what was tested. I showed it multiple times in this presentation. Pipe depth, pipe size, reverse order, pipe size, pipe depth, pipe orientation. Those are the 3 things that you need to validate for Aquastar covers to meet the VGBA 2017.
This question is there a specification for how the elbow inside the sump needs to be attached, or only if that needs to meet the distance requirements specified by the manufacturer?
That is an excellent question. So I covered the physics, the hair is going to follow it. Let's say it's press fit, or this is a threaded fitting and it's threaded in there and then pressed on. If this were out of the pool under pressure, it might drip water, and that's bad. It's suction in the pool, irrelevant to the flow rating and hair test. Okay. So it does not matter because a cover's got to be in place. And so people can't get at it to pull it off. Right. So if it can, elbow and pipe can be glued together and then inserted into the sump, that's what I would recommend. But one thing is you have to be able to service or winterize and check for leaks. So you have to be careful. But from a safety and compliance point of view, it's okay either way. Now, you don't want something that's so loose it's going to rotate and all of that kind of stuff. Use good engineering judgment. And that's really where I'd encourage health departments to rely on their contractors to get that kind of detail right.
Yeah, I'll try to read this word for word. For what Steve just explained, how does that work regarding example provided for modifying the 12 by 12 sump to be an 18 by 18 sump? Does EHS need to verify S?
There's a lot in that question, but I'm going to focus on the F. The only reason to be looking at F is if they're trying to use the original pool was inch and a half. Now they want to use the flow rate of a larger pipe size. And that's where, let me back up a little bit. That's where we need the 16 inches for F to comply. Where it would matters is if this were in here, this is an inch and a half sump, even though inside here it might be a 3-inch socket. So the only reason you need to worry about F is when they have done a remodel to go from a smaller size to a larger pipe size. And then they want to make sure that it's 16 inches from here to where they reduce, typically a T. I've never seen it in new construction that's not true. I got one example where it was a great big sump like this with small pipe, like I just said. But generally speaking, I don't, it's going to be such a unique thing that as a rule, you probably don't even need to worry about it. If a contractor is doing this, going from inch and a half to 3-inch or 2-inch or something bigger, they're going to know why they did it and the fact they did it. And I would encourage you to ask them, take pictures of take measurements. But again, I think the idea of a health department or authority having jurisdiction climbing down in pools with tape measures really should not be their responsibility. We need professionals to do that job. Those professionals need to document that they do the work correctly, is my personal opinion.
I have one more general question and we'll conclude after this. And I'll be sharing everyone's questions with Steve so that he can spend more time looking at them. Last question. Are EHS or public health enforcement professionals required to verify all measurements as set forth in the installation instructions for existing pools?
So that is going to be a local jurisdiction policy. Under federal law, the VGB Act can't make anybody do anything in this regard. So it is completely up to the authority having jurisdiction. DuPage County would be one example. What is your policy of going in and validating this? I would encourage all health departments to sort of follow the model of like North Carolina and Las Vegas and a few other places to name some, that they want to see pictures, they want to see forms. And I know DuPage has one that they fill out and sign off. I believe that's good enough. So I don't think it's necessary.
Thank you. Thank you so much, everyone, and have a wonderful day. Thank you, Steve.
My pleasure. Have a great day, everybody.